Hello, have you heard about COPD in regenerative medicine? No? Then now is the time. COPD is characterized by chronic obstructive pulmonary disease that affect many people across the globe. But how do they happen? Well, they result from an abnormal inflammatory response of the lungs to the inhalation of toxic particles or gases, especially cigarette smoke. That is, in trying to protect us from these harmful substances, our body ends up triggering an uncontrolled reaction by our defense cells. As a result, COPD can develop in the following way. Initially, there is exposure to irritating agents, primarily cigarette smoke, but also environmental and occupational pollutants. These substances irritate and damage the bronchial epithelium, which is a layer that protects the airways through which air passes on its way to the lungs. It helps to clean the air and remove impurities before they reach the lungs, like a filter. This leads to activation of the innate immune response, that is, our defense cells. Cells such as alveolar macrophages, epithelial cells, and dendritic cells detect these irritants. As a defense mechanism, they release pro-inflammatory cytokines, such as IL-8 and TNF-alpha. Moreover, neutrophils release proteases, enzymes that degrade the extracellular matrix, which functions like a mesh that holds and connects the cells. However, this molecular defense mechanism causes an imbalance between proteases and non-T proteases, increasing the destruction of lung tissue. This destruction leads to obstruction of the small airways known as bronchioles, fibrosis and hypertrophy of the mucous glands, causing hypersecretion, and emphysema, which is characterized by the destruction of alveolar walls, resulting in the loss of lung elasticity. Emphysema is one of the main components of COPD and refers to a lung condition marked by the destruction of the alveoli. But what are alveoli? They are small air sacs in the lungs where gas exchange takes place, oxygen and carbon dioxide. The alveoli rupture and merge, forming larger and less efficient spaces, as if several small bubbles turned it into one large bubble. This reduces the surface area available for gas exchange. Therefore, as a consequence of this mechanism, we have loss of lung elasticity. That is, a healthy lung expands and contracts like an elastic band. In emphysema, it loses the ability to recoil during exhalation, making it difficult for air to be expelled. This impairs blood oxygenation. In other words, fewer functional alveoli equal less oxygen reaching the blood, and consequently, less oxygen reaching the tissues. According to the World Health Organization, COPD affects over 250 million people worldwide and is responsible for more than 3 million deaths annually, making it the third leading cause of death globally. In this context, cell therapy using stem cells has emerged as a new therapeutic approach. The collection and expansion of the cells occur as follows. The cells are collected from a donor or the patient themselves. They are expanded in vitro under sterile conditions to reach the required number. They are tested for viability, sterility, and identity markers. After preparation, the cells are administered intravenously under controlled conditions. Mesenchymal stem cells, usually derived from bone marrow, adipose tissue, or umbilical cord, have the ability to migrate to areas of inflammation or injury, differentiate into pulmonary cell types, and release trophic and growth factors that stimulate the repair of the pulmonary epithelium and reduce alveolar destruction. But how do the cells know they need to repair damaged tissue? Well, mesenchymal stem cells detect chemical signals released by inflamed lungs, such as cytokines and chemokines, and migrate to the site of injury. It's as if they smell the inflammation and head towards it, as though following the molecular GPS. Once there, they release a variety of trophic factors and signaling molecules that act on local cells, for example, HGF, VEGF, which improves blood vessel integrity and vascularization, KGF, which promotes proliferation and differentiation of type 2 pneumocytes. These molecules act like SOS messages that tell local cells, regenerate, repair the epithelium, survive the damage. Inflammation in COPD is persistent and destructive. Mesenchymal stem cells help regulate the immune system by reducing the activity of inflammatory cells such as CD8 plus T lymphocytes, which are cytotoxic and attack lung tissue, and neutrophils, which release destructive proteases like elastase. They achieve this by releasing IL-10, an anti-inflammatory cytokine, TGF-beta, which promotes immune tolerance. In other words, calm down immune system, you're overreacting, let's get this under control. However, these innovative and promising techniques still faces some challenges such as low alveolar differentiation, meaning limited ability to turn into mature lung cells. A significant number of cells are lost after intravenous injection, and regenerative medicine therapy remains costly and is not widely available outside clinical trial protocols. Isn't regenerative medicine fascinating? I hope you enjoyed learning about the power of science. Bye!